Section 14, finding relative extrema. All right, this is a pretty big section. First thing is I'm very commonly going to be testing you to find critical points. It's the first step of finding relative extrema. Critical points are basically anytime the derivative tells us something interesting is happening with the function. So either the derivative is 0 or when the derivative does not exist. Those are interesting things because that's where our function is turning around. So the derivative is 0 there at our maximum, 0 here at our minimum, 0 there at our saddle point. If we had a crazy function like 1 over x, we could tell from the derivative of 1 over x that something crazy is happening at 0 because there's a discontinuity there. I can tell that from, like, hey, if I took the derivative of 1 over x, I would get, and this is x to the minus 1, I get negative x to the minus 2, which is negative 1 over x squared. And if I plug in 0 here, I get a problem. It's a discontinuity, so I can tell even from the derivative that something crazy is happening at 0. All right, relative extrema are more specific. They're where do we have relative maximums or minimums. Relative maximums are just where the function's at a high point and it goes down on either side. This is not the absolute maximum. It's not the highest points on the function. This function just keeps going on over here. Just like this isn't the lowest point in the function, but it's lower than to either side of it. That's what relative means with regard to minimum or maximum. All right, that's enough talking about stuff. Let's do a problem. So first, it says find the critical points of that function, f of x is equal to 13x plus 26 sine x. So first thing we do is take the derivative. F prime of x is equal to 13 plus 26 cosine of x. That was easy. Now, I have to say what x values am I not allowed to plug in. Turns out none. You can plug anything into cosine. So we can just move straight along to where this is equal to 0. 0 is equal to 13 plus 26 cosine x. Now we subtract 13 from both sides. We get negative 13 equals 26 cosine x. Divide by 26, and we get negative 1/2 is equal to cosine of x. So we just need to figure out where the cosine of x is equal to negative 1/2. Gonna the good old unit circle here. Let's see, cosine is our x value, so that's going to be here and here. This is, well, that's the pi, so that's 2 pi over 3. And that's 3 pi, and we're going, or 3 pi over 2, we're going back pi over 3. So that's going to be 4 pi over 3. So those are our possible values. Additionally, we could add 2 pi or subtract 2 pi from each of these. And so we could get other values. Really, it's just 2 pi over 3 plus 2 pi k and 4 pi over 3 plus 2 pi k, where k is all real numbers. Or all positive integers. I mean, because I did plus, I need it to be all real integers. Or yeah, I should have called this all positive integers. My bad. There. No. All integers. Very undecided here. But basically, I can plug in any number 1, 2, 3, 4, 5 for k, and I just get all the possible values. So this is one with like infinite possible values. This function has a derivative of 0 at several points on the interval. Sorry about the confusion there. 2 answers. Our second one, here's one where we have a very obvious discontinuity. we have a 0 on the bottom is bad. So x equals 0 is instantly one of our critical points. And now let's take the derivative. We get okay, what do we get? Bottom d top minus top d bottom is 1 all over the bottom squared. Okay. Obviously, 0 is still a problem on this x squared on the bottom, so we'll just look at the top and see where that thing has problems by setting it equal to 0. And by problems, I mean where it's 0, because we care where it's 0. All right, I should probably distribute all the things just to make things clear here. So 2x squared minus 2x minus x squared plus 2x minus 1. All right, this kills that. 2x squared minus x squared is just positive x squared minus 1 equals 0. Oh, this just got a lot nicer. Where is x squared equal to 1? Well, that's at x equals 1 and x equals negative 1. So if I had to find all my critical points, I should pull this guy down. And these are the guys. X equals 0, x equals negative 1, x equals 1. So again, I had to check where it was undefined and where it was 0. I got these two from checking where it was 0, and I got the 0 term for checking where the bottom was 0 or where I was undefined. And that's kind of how this goes. You're just going to find the derivative, figure out where it's either undefined or 0. And that's relative extrema.